algebraic combination of functions. We have the five. Now, the definition of algebraic combination of functions is already self-explanatory. Algebraic combination of functions is a combination of functions where we use algebraic operations. We have plus, we have minus, we have multiplication and division. Now, I'll write something like this. Let's say we have f of x, then we have of x. Something like this. It's a combination of functions in algebra. You can also express this as this and this, they are the same thing. You can write it like this, you can write it like this. You can do something like this, and you have to look for the solution to this. Let's say f of x.
Don't give example, just go ahead.
Okay, let's say just give us a list of x3. What we do is we put the value for f of x, we have and we get the answer. Just like that. Same thing for division, same thing for multiplication and subtraction. It's already there. It's just as if that together on the right. So we have. You just know that this is representing something and this is representing something. When you use the operator between them, you get your output value. That is just everything about algebraic combination of functions.
That's all. Yeah. Okay, you that one, the one in that shirt. If you are giving terms in terms of x, because he has said it's all about combining the terms either by addition, subtraction, multiplication, or division. Now, if you are giving terms in terms of f of x, and you have another one, g of x, let's assume the terms, the functions that you have, they are up to 3. H of x, and you are asked to add and subtract. How do you do them? How do you combine them? What do you do? You do same thing. What's the same thing?
Maybe they give us example f or g of h.
Yes.
And addition.
Yes.
First of all.
Look at the people you are talking to.
First of all, bring out the value of f, then bring out the value of h, then bring out the value of x.
Yes, after bringing the terms out, yes, what do you do?
Then you add them together.
You add them together. What's your name? What's your name? Ogogo. Yes. Can you go there and tell us? If you are giving terms, assuming you have 4 functions, f, g, h, and maybe b, all of x. Now you are giving expressions, and you are asked to carry out either addition or subtraction, or not multiplication, addition or subtraction. What do you do?
So we get our value.
Yes.
Bracket. Then assign addition.
Can you hear him?
Put addition in between the brackets or subtraction in between the brackets. Then we take each value, adding or subtracting them by their power. So if we have x raised to power 3, we add the x raised to power 3. Then we have x raised to power 2, we add them or subtract them based on their powers.
Okay, what he's trying to say is that after expressing them, that you should do collection of like terms. That's what he's trying to say. That you should do what? Collection of like terms. Yes. Do you agree to what he said? Go there and tell us what you have learned about algebraic combination of functions. Yes.
Algebraic combination.
What's your name? Atanga, what's your name?
In algebraic combination of functions, we have addition, subtraction, multiplication, and division.
Can you tell us what you have learned about algebraic combination of functions? Or you don't know?
We have the addition, subtraction, division, and multiplication
the noise?
Um,
Okay, thank you.
What about
My
this?
friend, my guy, can you go there and tell us what you have learned so far? What's your name? Gloria.
what I've learned about algebraic combination of function is
Can you hear?
what I learned about algebraic combination of function is we have subtraction, addition, multiplication, and division. And if I'm giving an example of this,
Can you hear? Yes. You are kidding. You fail. By the time you fail, don't blame anybody. Yes, go there. Come and tell us what you have learned about functions. Algebraic combination of functions. What's your name? Eddie.
Algebraic calculation of function is all about when you are given the power, like power.
Eddie Joseph.
Algebraic function deals with combination of division, addition, subtraction, and it's always about the power. If there's a multiplication, you add the power. If it's not multiplication, you write that power.
We don't understand what you are saying. Let me just ask you, based on what your presenter said. Now, if you have three functions, okay, let's limit ourselves to two functions, and you are asked to multiply the two functions. What do you do?
We are asked to multiply two functions.
Yes, because he said the combination is about either by adding them or subtracting them, multiplying or by division. So if you are asked to multiply two functions, what do you do?
And
You add. If you are asked to multiply them, you add.
you add the power.
You add the powers. Okay, oh. Yes, come and tell us. Give me two functions. If you are asked to find the product of the two functions, what do you do? To multiply the second bracket, yes, then you add the powers.
in terms of multiplication,
Eh,
when you have
yes, you have opened the brackets now. You have opened the so what do
then
you
you
do?
collect items.
Yes, I like that. Go in. Yes, come in. Can you tell us all that you have learned about algebraic combination of functions? What's your name?
Take success now.
Look at the people you are talking to.
When we are talking about algebraic combination,
Can you guys imagine this food? Hello. Is the police. Yes. I didn't say you keep the noise. Yes.
if we are talking about algebraic combination of function, if we are talking about, let me say this SN for if here we have one and we have four, if it's multiplication, we add them together. Then if it's addition or subtraction, we don't add them, but the powers are normal.
I don't understand what you are saying. And you are even combining your hands. What are you?
Okay. And if, for example, we have one,
Okay, I want you to restrict yourself to assuming you have two functions and the operator in between them is subtraction. What do you do? You have two functions, f of x minus g of x. You want them to whisper to you. Listen to me. If you have f of x minus g of x, what do you do?
you add.
Which of the function is the sign, the operator? I've got to do it. Yes?
X value.
X value. Okay, thank you. Anybody that's here to say something? Or everybody has said something?
Yes.
Oh yeah, thank you very much. You can go inside. Can you clap for them?
Hello everyone, we have been today and we are here to present on the topic algebraic combination of a function. And algebraic combination of a function has to do with solving of either adding, multiplying, multiplying, dividing, or subtracting. Then we have basic operations of algebraic combination. We have addition, we'll say f plus over s. And also the written as f plus b of x. We have the subtraction. The subtraction is almost the same thing as dot sign that changes this. And can also be used in this form too.
Can you do more of the talking?
And we have division of algebraic combinations. We just deal with numerator and the denominator. Then the multiplying can be written as f of s f plus g over s. Can also be written as f of s plus g of x. Then we talk about the reciprocal of the function, where the reciprocal of the function can be written as 1 over f of x. Then, for example, we have 2x plus 2. Can be written as like this 2x plus 2. Then, in case where scalars are being multiplied, we can, where there are real numbers, we can say, for example, one scalar is alpha plus beta. You can still write it as, for example, like this. You can write it as alpha of x plus beta of s. So this is all about algebraic combination function.
This is all that you know about algebraic combination. Yes, thank you. My friend, are you hiding and talking? The police. Now, he's saying that in case you have some scalars that are associated with the various functions, would you want to say something about that? First of all, do you all agree what he said?
Yes, sir.
Yes. Now, if that's true, then he's saying that there are some scalars that that can be associated in terms of alpha and beta. Now, can you please say something about this?
For the scalars.
Assuming you have a scalar in front of a function, and you are asked to add them. You are asked to add the operator between them is addition. What do you do?
No addition.
What's he saying?
Same thing, like for scalars, we are the same thing with the normal function addition.
How do you mean by the normal function? You do understand what your presenter said? He said there is the possibility that we might have scalars. Okay? Of this. Now I'm saying that if there is an operator plus, and you have, say, beta of h of x. Now, how do you romance this? How do you solve that? You can say something. Tony, can you help him? Yes. It's your presenter that said that there is a possibility that scalars can be associated. And I asked you, do you agree to what you said? You said yes. Then if that's true, then if you have an operator, say plus, in them, what do you do? If I come down, I will slap you. Did I say submit the thing to somebody? Are you not ashamed of yourself? Idiot. Attacker. Who is attacker? Who is Clinton? You want something? Nikki. say. Yes, you that they are coming help out, please. Your presenter said there is a possibility that we might have some scalars. Yes, that possibility is there. Now, if we have an operator in between, say plus, how do you simplify that? How do you deal with that?
For instance, if you are given a scalar like this, you use this one to multiply the function, then this one to multiply this function, then you add them together.
Before you add them. Okay, that's beautiful. I like that. You mean that we have scalars, you have to use the scalars to multiply the various functions. Then you begin to add them by collecting like terms. That's nice. Yes, you, Blackie, what's your name? Is she talking?
Variable agreement.
Can you tell us all that you know about multiply combination?
Mostly, what I understood most in algebraic equation is the addition and the subtraction.
Not algebraic equations, algebraic combinations of functions, yes?
Algebraic combination is the addition and the subtraction. I also learned that being algebraic equation is just the representation of algebras from later from alphabetical order. They could be represented by any letter, and also when adding them is the individual letters, the values of the individual letters that you're adding. They don't have anything to do.
How do you mean by the values of individual letters?
For example, when it comes to addition, say here.
Is that all? Is that what I said on the platform? Because I want you to tell us what you are studying on the map, or you are telling us what you know. That should be a different class. Now, this one, I want you to tell us what I said. I said. Because you people are sort of saying, sir, you said. Yes, what did I say? Yes.
What you said in the platform is concerning the addition is the values.
What values?
The x values.
Yes, my friend, can you help us, please? What's your name?
Very easy.
Very easy. Can you help us? What have you learned, yes, concerning algebraic combination? I didn't say you should talk about it. It's you that said that's what you want to say. Yes?
Okay. I learned about algebraic functions by adding, subtracting, and multiplying. And now we'll talk about the addition. Because when we talk about the addition,
Very what?
Easy. Easy.
Easy. Who asked you to pause?
so when we talk about the, I'll talk about the multiplication of this thing, algebraic combination. So here we have, for example, we have f of x values plus g of x values, and we are given to multiply. If, for example, we have 3x plus 5 as the f of x values, then for g of x values, we have 6x.
Okay, my young man, please. If you have scalars, your people said that the possibility that we can have scalars associating with the various functions. Now, that operator, assuming that operator, can you remove that plus there and put minus, yes? Can you just say noise this food? Yes? Now, can you say something about that minus?
About the minus.
Yes, that minus.
First of all, use the scalars to multiply the
The
value.
various functions, not values.
Sorry, various functions.
Yes.
Then the first of all, you
You have said first of all now. The first of all, you have used the scalar to multiply them, yes. Then they have to say something about that minus.
use their powers from
They have
their
started again.
before, because if for example, let me say we
Oh
have
no, don't give us example. That minus there.
Yes. The subtraction,
Yeah.
the minus sign affects the h of x versus money. So when you are
Why?
because they are all in bracket. So if there is no bracket, it affects only the value here. But since all the values are all in bracket, the minus sign affects.
Affecting everything there. Yes, I like that. You have not said anything. Can you tell us all that? What's your name?
I'm pretty Joseph.
Africa.
Algebraic combination of functions are functions that have to do with algebraic operations, and the algebraic combination of functions can be expressed in addition, subtraction, multiplication, and division. There are special cases of algebraic combination of functions which involve the reciprocal function. The reciprocal function is the one in which there is a 1 over the function itself, and that of the scalars. The scalars are attached to the functions. So the scalars are to be multiplied to the various functions before the operation can be carried out. That's all I know, sir.
That's all that you do. Can you tell us something more about the scalars with the functions?
The scalars are the set of real numbers, so they are actual numbers that are multiplied to the functions before the operation is carried out. The addition, before the addition, which is the collecting of like terms, or the subtraction or multiplication or
Okay, now
division.
look at this. Look at what we have here. I want you to remove that negative sign. Assuming the operator there is multiplication. Put dots there. Yes, then what do we do? How do you simplify it?
In multiplication, when the functions are given, the f of x function is to multiply each value in the f of x is to multiply through all the values in the h of x.
With with what we have there, if you have a scale that you already stated,
Okay.
that they are a big number 10, that if you have it that way, what do you do?
If you have this way, the scalars are to multiply through the f of x values, and also the scalars here is supposed to multiply through the h of x value before the multiplication can take place. And in the multiplication, the f of x values each value of f of x has to multiply all the values of the h of x before you collect like this.
Okay, is there anybody that is still here to say something? Have you said something? Can you come outside then? Can you please say more about what I asked at the last question? Assuming we have the two scalars and the operator in between is multiplication. How do you simplify that?
Okay, if you have two scalars, first of all, what I understand, we are going to bring
Are you seeing his face?
Yes.
Can you please face the camera?
If we are two scalars, first we are going to bring out a particular number to
A particular number, where is the particular number coming from?
in a number from the subsequent.
The scalar is there now, alpha. You don't know the pattern is alpha, the pattern is beta.
Yes, but to represent them, you can
I don't want to represent them, I want to use the alpha and the beta.
okay. You use alpha. You use alpha to multiply everything inside the f of x. Then you use
Beta,
to multiply everything inside the h of x.
yes, then you do what?
Then you collect like them.
Like times, there is an operator there. You are not talking about that operator, the multiplication operator, in between this side and the other side.
Okay, you multiply.
You multiply this one again. Thank you very much. Can you come back on that? Okay, can you go there and help him out, please?
When we are given scalars, what we tell you,
Quiet, yes.
when we are given scalars, we use the scalar to multiply a function. Like this, now we use this alpha to multiply f of x, and we use beta to multiply h of x before doing the multiplication. When we are doing our general multiplication, each value of the f of the already multiplied f of x is multiplied through with the with the beta h of x. Each value multiplied.
Then after the multiplication, what do you do?
Then you collect the like terms.
Okay, can I come for them?
Good evening, guys. Okay, this is group 2, and we are here to present two topics from calculus. And the two topics are algebraic combinations of functions and piecewise function. But I will be starting with algebraic combination of function. But I'll not be dwelling more on algebraic combination of function. I will leave it out for my group members. Okay. As well as when we are talking about algebraic combinations of functions, we have different types, which are the addition, the subtraction, multiplication, and division. Then under that, let me just throw more light on it. When we are giving f of s and we are told to add it to g of s, here you just bring out if at all you are giving value, bring out the value, add it. Take for instance, now we are giving subtraction, here now be subtraction, just subtract it. Multiplication, same thing, but in subtraction, you make sure that this second part, which is our right hand part, you make sure that you bracket it. Let's say g of s is 2s minus plus 1, and f of s is equal to 2. Bring these things down, following this minus, you'll be having 2 minus, you first of all put bracket, then you write out 2s plus 1.
You must not put brackets. All that you have is that the negative sign is affecting everything that has to do with G of x. Is that what you're saying?
Yes, sir.
Okay, continue.
So, in the sense that this minus sign is affecting these things. Take for instance, now we are having plus. You put bracket or not, or you leave it like that, it will still be the same thing. So this minus will now come to this place. This thing now will now turn minus. So after that, we also talked about the reciprocals in algebraic combination of function, and we also talked about the scalars, where we have alpha and beta. We use that from the YouTube video. Where you have alpha and beta, and use alpha and beta, which are like a constant to open the bracket, which is the f of s. Then beside that, I will be rushing down to piecewise function. When you are talking about piecewise function, we are talking about sub-functions that are in one function. They are just like a home where you have father, and the father is the father to all the children, no matter the numbers of the children. So the piecewise function deals with baby function inside itself, and from that.
So you say the father as the father of God. So even if the woman choose to bring another person's child, is the father.
And
you agree to that? That the father is the father of all the children. So even if my wife chooses to go and sleep with another person.
Okay, and that's not so acceptable. Okay. Or to make it understandable to us, we can say the piecewise function is talking about the collections of sub-functions. It's the collections of sub-functions. And let's say, in respect to piecewise function, the way we usually write piecewise function, you can see this way that f of s is equal to, you must see these things, something like this. Let me write it in a, where you can have 2, 5, 7, and then from here you have something that, let's say, assumable numbers, like let's say 5 is less than s, less than or equal to minus 2. Then here you can still have numbers like 2 less than s less than
Can you please
or
be
equal
more
to,
talking?
okay sir, 2, 3 less than s equal to 4. So this is how piecewise function is being present. Now whenever when I give something like this to work on, your mind will just go straight to piecewise function. I'm talking about the way you plot piecewise function graph is different from the way you plot your normal straight line graph. Piecewise function do not deal with straight line graph. You plot your graph in the sense that you be having, since it's sub functions, these are the sub functions. Your graph now, you now be having lines that are separate lines. You not be having combined or joint line. Something like, let's say you have something like this. Let's say you have your piecewise function, your graph will not be this way. Your graph will not be this, way. If will not be this way itself, your graph, the way you see your piecewise function graph is, if you are having sub functions, since we are talking about sub functions, we are having this one tends to this one. I'm just doing this for the sake of time. Then you can say something tends to this again. You shade this part, means that this part is not taking the value that is here. You shade this part, this value now, it says here can be let's say plus -1. -1 tends to this, let's say here is +4. -1 tends to +4. So this part is not taking, this part is one that is taking. You can also have something, you shade this part. So this is the way piecewise function is being represented on a graph. It's not represented this way or this way. It's not a straight line graph. It's not parabolous. So this is the sub functions, collection of sub functions. You can see this one is one, this one is one, this one is one, separate things. So I believe from that is all I can say for now about piecewise function and also the algebraic functions.
Those guys there, please, can somebody say something about the piecewise function? We are not seeing what they say.
My name is Bon. I want to, a piecewise function is a function that is made up of other smaller functions. For example, a woman.
You don't need to write it. Yes, enough.
A woman that is a pregnant woman that is carrying three.
Pregnant woman again.
That is carrying 3 children. That is, the woman is a function. Let's say, for example.
Don't say it. We are written them. No, don't see that they are correct. Are they not correct?
That is great about.
The ones he has written, are they not correct? If you are correct, can you say what he has not said? Must you use a woman? Because I say use what you said now. But we are talking about a woman now. You like the woman? That's the woman. So you can because our program is about to draw women, and we don't seem to draw women, so how do we talk about the women? Yes?
Good evening, all. But I'm not here to kick against what our leader has said. He spoke well, and he was correct in what he said. But I'm here based on what I watched on the YouTube channel. Well, all I will say is that a piecewise function are sub-functions that make up a function.
Beautiful.
There are sub-functions that make up a function. So, and also, the sub-functions are used to get the domain and the range of the big function. So, let's say,
you don't need to write it. You just what he said is after the so please can you just make that he did not say.
I think the right thing is explain better.
No, like say it. The thing is on the platform. If they want to see, they will go there.
So, like I said, we use the sub functions to get the the domain and the range of the bigger function. So,
Yes, my biology. Can you say something?
Like we have all been saying here, using the pregnant wife and husband as example. A piecewise function it's all about just how the f of x value is divided into smaller functions. This small function are what makes up this f of x value. So piecewise, anything once we come to the topic called piecewise, we're talking about the smaller part of the function. The thing that makes up the function, the smaller part. I don't know if I'm allowed to draw on the board to explain better. They have not said what they have said that is everything about piecewise function. I don't know what else I can say that will put in more light into what they have said, but what they have said is what I'm also going to say.
You are just adopting all that they have said.
No, I'm not adopting.
You don't have anything to do. So how are you now? How are you because you said you are adopting all that they said.
No, they have said everything.
Yes, that's my experience with classes. It is mid-range or something like that.
Yes, sir.
Can you help us?
Piecewise function is a combination. Piecewise function talks about a combination of different sub-functions that are used to make up a bigger function. Like he said, the sub-functions are known to find the range and the domain of the function of the bigger function. According to what our leader drew, if you want to plot a graph in a piecewise function, this part of the graph is mostly known for the y-axis, while this part of the graph is for the x-axis, where you're using to find the domain. This function that you do is a constant. This is a constant function, which makes it easier for you to find and plot the graph. Unlike other functions whereby they are algebraic and you have to solve it.
Is that all? That time you said something that you didn't say. Yes, is it a camera?
Okay, as my colleague has said, what do you mean by a piecewise function? A piecewise function is a collection of different sub-functions that each of those functions will determine the domain and each of the domain will determine the range. For instance, you do something like this one. You consider this part of the values the domain. These values here that are called the domain will determine the range here. Or for instance, if you have something like x.
You're talking about that's the domain of the function.
Domain of the
function. You have already said they are function. Yes. And you are talking about the range.
This one is the domain value.
Yes.
The domain value to find the range value. You find the range value from the domain after gotten the
that two. We have two there now. Are you adopting that? Or you want to write your grammar?
This one.
Yes. What type of function is that?
This one.
Yes.
Constant function.
It's a constant function. Now, how do you get the range from that?
Like, when you find the domain, it's from the domain that you find.
What's the domain of that function?
The domain of x is less
What are the values of what are the domain values of that function?
domain values
Which one is it?
domain values.
Yeah.
5.
Is what?
5.
5. Can you read what is there? Swani, what did you write there? The first term there.
5 is less than
5 is less than what?
x
X.
less than or equal to -2.
That kind of thing.
Yes.
What did you write there that Ben Johnson do? That's it. I'm happy for you because you can say something. Yes, you get it from Agapi. Go there. Can you tell us about all that you have learned about they are piecewise functions, or they said you can also talk about algebraic functions. Yes? Can you tell us more about the algebraic functions? If you like this piecewise, but you were there and when you said you people want to talk about algebraic and algebraic combination of functions and piecewise functions. Tell us the one that you are
Piecewise function is a combination of sub-functions.
Sub-functions, yes?
Yes. Where this part is the domain. Then
assuming you are adopting that part, the other thing is wrong. Yes.
this part is the domain and is used to get the range.
How do you get the range? Okay, now I want you to look at it. Point to the second one, the middle one. What is the function in it?
5.
Biology, you are not expected to talk. Don't tell me that you are a particular real boy. You are telling them, is she from biology? Are you in biology? Is that why you are giving her expo? Yes, you said the function is 5. What are the domain values? Yes?
2 and 2.
Can you read what is there? Just read what is there and do it.
2
You
less
are
than
talking
x.
smally and your man is why do you cover your mouth?
2 less than x less than equal to 2.
2 is less than x, less than equal to 2. Now, wow.
2 less than x. 2 less than x strictly
I'm asking that you can say something. Yes, the other of my girl, I'm assuming a woman, yes? Where are you from? Delta. Okay, Delta woman. Can you tell us, say something about the algebraic combination of functions?
The algebraic combination of functions involves the combination.
Or which one will you want to talk about?
I can say anything.
Anyone. Because if you don't say anything about algebraic combination, I will assume that you have just covered piecewise. Because everybody is talking about piecewise and not algebraic. So
Algebraic
so that you can cover that.
Algebraic combination of functions involves the calculation of functions using addition, subtraction, multiplication, and division methods. There's also reciprocal of functions.
Why are you eating your forehead? There's a thing there. Functions and that.
Talking about reciprocals of functions, it means that I will use 1 divided by a function. That is all about reciprocals of a function. Now, talking about scalars. Talking about scalars, using scalars to multiply functions. Now, when you're using scalars to multiply the function, you use the scalar to multiply the function before taking like terms or going forward to the operation involved. So if you're giving a function f of x, you're using this scalar to multiply the function. Using the scalar to multiply the function, then you use the operator here given to you if it's addition, subtraction, or multiplication before taking like terms and getting your answer.
Yes, thank you very much. Can you clap for them?
Alright, good evening class. This is group 1 will be touching on algebraic combinations of functions. In algebraic
Now,
combinations,
where are the other persons? That means in this system, where are the other persons?
some have classes. Some have classes.
Some have classes, okay. So everybody's aware that we do presentation, right? Are they aware that people are presenting today? Yes. Are they aware? Everybody doesn't make a decision here.
They are aware.
Oh, these guys, are they aware? Everybody's aware that people are making presentation today.
Yes, sir. Yes, sir. We're talking about algebraic combinations of functions. In algebraic combinations of functions, we're looking at how different multiple functions can be combined. One, sir. Either by addition, subtraction, multiplication, or division. We'll also consider special cases such as the reciprocals and scalars. Okay, for that of addition, let's assume we have a function saying f plus g, all of x, where f is a function and g is a function. We're saying that can be written as f. We have
Now, the girls, do you agree with the little one that they are saying? Can you come and add to what they are saying? If you see how something is
We are talking about combination. We are talking about the kind of combination that is combining the functions to get the same domain. And we are talking in algebraic combination, you have the addition, subtraction, multiplication, and division. We are talking about the addition, for example, and we said that f plus g. For you to get the function here, you write down the f value and the g of f, then you collect the like terms to get the answer. If it's by multiplication, you still do the same thing, but the sign here will change to minus. But if it's multiplication, if it's subtraction, the sign here will change to minus. But if it's multiplication, you make use of this f here. This f of x will multiply every
my brother, can you help her? She has said something. Can you help her? People are talking about algebraic combination of functions. Can you say something about it?
You see, like what they say that the adding, subtracting, multiplying, and dividing of functions.
Can you hear it? Can you clear the noise? Yes, yes. What did they say? Yes?
According to them, they say that it is
according to who?
My group members.
According to them. So they know what you say.
Okay. The back of this function is simply defined as the adding, subtracting, multiplying, and dividing of functions. So going to the example, like x.
Can you hear it? Yes, sister, can you hear me?
Yeah. We say that we are saying that algebraic combination is the adding, the multiplying, dividing, and the subtraction of function. For instance, we are having f of g all in.
Now, can you talk about the cases where maybe we are introducing some scalar quantities like alpha, beta,
okay,
and
if
yes?
we are introducing some scalar quantities, let's say we have alpha f all of S.
Our voice is very low.
Plus
beta.
Good evening, everybody.
Can you let the noise, please?
Please,
Can you let the noise?
So we are talking about algebraic combination of functions, and algebraic combination of functions is all about where multiple functions are being carried out by operations, which are by adding, subtracting, multiplication, or division. So we have special cases.
Now, what if we have some scalars? I just want you to restrict yourself to that. If we have scalars attached to the various functions,
if we have
to maybe add them or multiply them, talk about those two.
So if we have scalars multiplying to the function, first of all, you use the scalars are constant functions. They can be any number. So when you are using scalars to multiply the function, you first of all use the scalars to multiply the function. Then after when you have multiplied the function, then you consider the operation, the operator which is there. Then after when you have considered the operator, then you take like terms. Then the power. We are talking about the power. Sometimes the power is like you come across polynomials. Like x might be raised to the power of maybe 3. Then the like terms, when you are taking the like terms, you share.
How can you help me?
When solving or the right combination, you ensure that the domains are the same. The domains are the same. Vector.
He said that we are all partial or combined functions that have the same domain, yes?
Same domain. Then once you ensure that the domains are the same, if you are given what you are going to calculate, then you solve them from their polynomials. The one with the highest power, bring it down till you get to the constant
But
terms.
in cases that they are not polynomials,
Then you add them. If it's by addition, you add them. The one on the f of x, you add them to the other ones. But if you are given from polynomials like x raised to the power of 3, like if you have the one that has the highest, then you write it down. Then you can
all right,
write the
thank
other
you very
ones.
much. Very pretty simple, very pretty simple. I've talked about algebraic computation of functions. I've also talked about piecewise functions that some of you talked about. And these things are very simple and straightforward. Now, the only advice I will give to you is it will be so bad that you come out to the podium and you will not say anything. They are there on the platform. I have also taught you of those courses, of those topics, and I'm expecting everybody to perform maximally, maximally. So please, 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 I'm begging your conscience to do your best. Now, when it comes to algebraic combinations, yes, all that you said follows. I know people will want to talk about it because it's a bit easy to talk about. Now, the other one is that of the piecewise functions. For piecewise functions, we have a lot to say, not just, yes, smaller functions making up a bigger function. If you say so, then you are okay. But you can see that the one that our brother talked about is a minor, so most of the presentations were not too okay. But then, it's more of f of x is given in terms of some smaller functions. Okay? Now those smaller functions have their own domains. Now the way the questions are posed most of the time is how do we determine the domain of this function? And I have said, and because I said that, I said it's a collection of all the subdomains. And nobody says something about that. It's a collection of all the subdomains. Okay? And sometimes we also talk about the range. This you can also do from these subdomains. So as we go on, it might not just be the algebraic combinations or piecewise functions. There are other things that we have also introduced. So I am begging your conscience, everybody. Now I choose to stop this last group because they are very few. Now, when you are coming, please inform your group members. Ensure that you people have an agreement that you are making presentation that day. Not because you are around, you want to come and present. Because when you do, any other person that is not around, I will assume that they don't want. And for that topic, it's over. It's over. We don't even have time not to talk of going back to assess other persons that did not know. I don't think I have that time. So I am please begging your conscience, take time. Like those idiots I'm talking and they are still talking. Are you listening to me or you are listening to yourselves? And in the end, you say you don't understand. Okay? Every normal human being, when I'm like a father to you, every normal human being, your father is talking and you are talking, meaning you don't respect your father. That's lack of home training. They didn't train you properly. I'm talking, even if I'm not up to your father, maybe as you will claim. Your lecturer is talking and you are talking. And if I ask you a question, you will say you don't know. That's act of stupidity. Please stop that. Now, I am begging your conscience, everybody try as much as you can to go online. It will not do you anything. When you go there, it's simple, simple as ABC. Those things that I am saying, they are translated in English. Okay? You can make note out of it. When you can be copying, you can be writing it. When you listen, you pause it, you draw what you want to draw, you continue, you make your notes. And when you are done, you keep studying it. Okay? Now, for those of you that are maybe using your data, 200, you can watch 2 clips, or maybe 1 plus. 200 naira data. Yes. Listen to me. I'm telling you the truth. These are things I do on regular basis. These are things I do. Now, the way video works is, as you are playing it, those of you that have eyes, you see that there is a white line that is going ahead. Once the system processes it, even if there is no network, it will be playing. Only when it gets to the point where it has not processed, that is when it will stop. It will start dwindling. So it's the same thing. The one that I know takes data is uploading. Okay? And because that uploading, even when you upload half or some seconds to go, and once the network dwindles, it will come down, to fall down, and you start from the beginning. It's not like downloading. When you are downloading and the network disturbs, it will just pause there. And it will just be knocking at the door. Till when the network gets better, it will continue. For viewing, it will start wobbling, booting, depending on when the network boots. So with small this thing, you can do it. But if you feel you don't want, you are comfortable with classes, all that I'm saying is learn how to get something done. So that when you come out, what you are saying here is what I will use to judge you. You grill, you know grill. That's what I will do. Now, as I am teaching, so pathetic, some people have gone out. Some persons have gone. Now, I will take attendance, and this attendance I am taking will stand for the day. Okay? Your lecturer is in the class. The class was far better than this, but some persons are out. So I'm going to take attendance, and that attendance will be for the attendance, today's attendance that I want to take will be the attendance for the classes that I have taken. All the classes that I have taken, today's attendance will stand in for that. And the lecturer has said it, and that's all. Thank you.